Hey guys, today we're going to determine how to find the sum of all the interior angles of any shape. So before we get to that, you have to know how many sides a shape has in order to name it. So you may remember back in the day that a hexagon has 6 sides. A pentagon is called a 5-sided shape, and the number of angles always matches the number of sides. So the number of angles an octagon has is the same question as asking how many sides an octagon has. Angles and sides in a regular polygon are always the same. So an octagon has 8 sides and 8 angles. And then you're also going to have to remember how to evaluate a problem. Evaluate just means solve. This formula right here is actually called the sum of interior angles formula. So a fancy way of saying you can figure out the sum of all the angles if you're going to n the number of sides. So if this is a 3-sided shape, also known as a triangle, we already know that has 180 degrees from the triangle sum theorem. Just to prove it to you, any sided shape, if I plug in the number of sides for n, s is a sum, 180, in this case 3 minus 2, PEMDAS, p to the e to the m to the d to the a to the s, PEMDAS, no stress, we do order of operations because it helps us to solve equations. When I multiply, I get a final answer of 180 degrees for my sum of all the angles, and in this case, in a triangle. I already proved that to you at the triangle sum theorem, so let's move on. Vocab, polygon, closed shape, no curves. A regular polygon is a closed shape with no curves and all angles are equal. Trapezoid has 1 set of parallel sides, the 4-sided shape. A parallelogram is a 4-sided shape with 2 sets of parallel sides. There are different types of parallelogram. You can get a rectangle, which has 4 right angles and 2 sets of parallel sides. A rhombus that has 4 congruent sides, but not necessarily right angles, And a square has 4 congruent sides and 4 right angles. Pause for a second and make sure you know those words. If you need to rewind and restart and hear it again, do it. So, pause the video and see if you can determine which one of these shapes are polygons and which ones are not polygons. I'll go back to that in just a second. Naming the shapes, if you look over to the right-hand side, they're color-coded. So a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6, heptagon 7, and octagon 8, and 9 is a nonagon, and you can also keep naming them if you'd like, but usually you end at nonagon. So back to what we said. Could you say that all the green shapes are polygon because they have no curves, and all the red shapes are not polygons because they have curves or they're not closed? So see if you can pause the video, and I have highlighted the number of sides each one of these polygon has, and can you name them? All right, how'd you do? So today's whole point is to find the sum of the angle measures in a figure. Any polygon that has a closed shape, it's a regular figure. You could either do method 1 or method 2. Method 1, you divide the polygons into triangles starting at 1 vertex and then multiply the number of triangles by 180 degrees. I'll show you both methods in this video. Or you can use method 2, which is using the formula s equals 180 n minus 2, where s is the sum of all the angles in the interior, that's the inside, and n is the number of sides. I'm going to show you both ways. Please pause and take notes as you need. So this first one, if you're given a shape that has a black diagram on the outside, you can start at any one vertex. A vertex is just a point, and you divide it into triangles. That's 1 triangle, 2 triangles, 3 triangles, 4 triangles. So each triangle we know from the triangle sum theorem has a sum of 180 degrees. So I could take 1, 2, 3, 4 times 180 to get s equals 720 degrees. Or a 1, 2, 3, 4, 5, 6-sided figure, hexagon, has a sum of 720 degrees. Another way to do this would be s equals 180 times n minus 2. Sum is 180 times how many sides? 6 sides in a hexagon minus 2. Parentheses first. 6 minus 2 is 4. And when I multiply 180 times 4, I get an answer of 720 as well. I just need to make sure to put the degree sign on. And the sum of all the angles inside a hexagon add up to 720 degrees. This is just showing it broken down the second way with substitution. I did the same thing on the previous slide. This is a little different shape, but it still has the same number of sides. In order to do this one, it might be a little more tricky, but you have to start at 1 vertex to divide it into triangles. 1, 2, 3, 4. And this one isn't as pretty, so I would probably go with this one just to make sure. This you could divide into 5 triangles. I'm going to start with this point here because I think it looks like the easiest. And you have to go to each vertex. 1, 2, 3, 4, 5. And the number of triangles you can divide into is always the number of sides minus 2, because the formula says 180 times the number of sides minus 2. So in this case, I have 7 sides. So I have 7 minus 2, which is 5. So I take 180 and multiply it by 5 to get my sum of 720 degrees. We just did this way, so I'm going to skip over to a problem that looks like this. This is a regular polygon. Number of sides are 6, so I just counted 1, 2, 3, 4, 5, 6. So the sum of all of my angles is going to be 180 times 6 minus 2. So that'd be 180, and 6 minus 2 gets us 4. And then to figure out my sum, I take 180 and multiply it by 4 to get 720 degrees. So a 6-sided figure, also known as a hexagon, has 720 degrees. This is a regular hexagon because all the angles are congruent and all the sides are the same. So that means that each one of these x's are equal. So if I take all my x's and add them up, 1, 2, 3, 4, 5, 6. 6 x's have a total of 720 degrees. If I wanted to determine what each x would be, this is like a squiggle problem. I divide each side by 6 to get the measure of each angle. 720 divided by 6 is 120 degrees. So in this regular hexagon, each x is equal to 120 degrees. This is a regular polygon, also known as a square, because all the angles and all the sides are the same. So the sum of the angles are the number of sides. In this case, we have 1, 2, 3, 4 sides. So I put a 4 in for n, and I'm going to subtract 2 from it, because that's the formula. So 180 times, what's 4 minus 2? 2. So the sum is going to be 360 degrees. If you wanted to do the triangle method, you just start at a vertex and you divide it into triangles. I have 2 triangles, so you could also skip to right there if you're just doing the drawing and do s equals 180 times 2 to get an answer of 360 degrees as well. If I wanted to find each angle measure, like this problem asks us to find just y, I want to count how many y's do I have. 1, 2, 3, 4. And y plus y plus y plus y is the same as 4y is going to have a total sum of 360 degrees. So to find each y, I need to divide 360 by 4. And when you do that, I'm going to come over here, y is equal to 90 degrees. That's pretty approximate. So if I took 90 degrees and added it 4 times or multiplied it by 4, I'll get the sum of 360 as well. And these do look like right angles. Let's move on. So this is a polygon as well. It has 5 sides, 1, 2, 3, 4, 5. We call this polygon a pentagon. So the sum of the measures in a pentagon is going to be s equals 180 times the number of sides, which is 5, minus 2. So 180 times 5 minus 2 gets me 3. So the sum is going to be 180 times 3, and I get 540 degrees. That's all the angles. So if I wanted to find each one, pause the video and see if you would do what I would do. So you counted up all the angles and you got 5a, and you know that all the angles added together would be a sum of 540, and you divided it by 5 because there's 5 sides or 5 angles, and you get each angle is equal to 108 degrees. If you wanted to divide into triangles instead of going to this formula, you go right to here. If you divided it into triangles starting at one vertex, you get 1, 2, 3 triangles, so you take 180 times 3. That's the first method. Now this is a polygon as well. All you have to do is count up how many sides it is. 1, 2, 3, 4, 5, 6, 7, 8 sides, so it's an octagon. The sum is 180 times the number of sides minus 2. So instead of filling in an n, I'm going to put in 8 because it's an octagon, 8 sides and 8 angles. And if it's a regular octagon, each angle would be exactly the same like it is in this case. So the sum of all the angles is going to be 180 times 6, which is 1080 degrees. If I wanted to find out what each side would be, I have 8 sides, or 8 angles, all equal to 180. If you divide it by 8, you get each angle equal to 135 degrees. This shape here is four-sided, has 4 equal sides and 4 equal angles. This is not looking like a regular polygon, but it is because you see that their sides are the same. So if the sides are the same, that also means that the angles are the same. So you have the sum of the angles is 180 times the number of sides minus 2, and I get 180 times 2. So the sum is 360 degrees. There are 4 angles that add up to 360. So if I divide both by 4, I get C is equal to 90 degrees. This could be the same answer because you have a four-sided figure, all sides are the same, so 360 degrees is equal to 4 times D. You can see it on this way too. Divide by 4, 90 degrees for each D. So make sure you have this in your notes. If you haven't picked it up yet, please make sure you do. This is classifying shapes. We're going to go for a quadrilateral. All four-sided polygons are called quadrilaterals, and then you can either go to a trapezoid or a parallelogram. The trapezoid has one set of parallel lines across from each other. So these two are parallel to each other. Our parallelogram has 2 sets of parallel lines. Those 2 are parallel, and those 2 are parallel. If it is a trapezoid, it ends there. It can be a quadrilateral and a trapezoid, but it can't be anything else. If you start a quadrilateral and instead go to the right to parallelogram, then the parallelogram can be a rectangle, a rhombus, a square, or a multiple of those. So let's go to classifying. If you're classifying this shape, it's a quadrilateral because it has 4 sides. That's the first step. Then you check to see how many sides are parallel. Well, those 2 sides are parallel because they'll never touch, and these 2 sides are parallel, they'll never touch, so we call that 2 sets of parallel sides, so it's also a parallelogram. Then I ask myself, well, does it have 4 right angles? Go back to that flow chart and it says the next step is saying, does it have 4 right angles? Well, this does, so I can call it a rectangle. Rhombus says it has 4 congruent sides. Well, this one says it has 4 congruent sides, so it's also a rhombus. It's a square if it has 4 sides and 4 right angles, so it's also a square. So all 5 names apply to this figure. This is a quadrilateral because it has 4 sides. It's a parallelogram because both sides are parallel to each other. And it's a rhombus because it has 4 sets of parallel sides, congruent sides. It doesn't have the congruent angle marks. This is a quadrilateral, 4-sided, has 2 sets of parallel sides, and these are supposed to be right angles. So you can also call this a rectangle. This is a kite, also known as a quadrilateral. Quadrilateral is the name that you'll be given. It's a four-sided polygon. It's a closed shape. It should be closed, but it does not have a set of parallel sides, so you can only call this a quadrilateral. If you wanted to find the sum of angle measures in a quadrilateral, you'd have to say that S equals 180 times 4 minus 2, and you'd get 360 degrees. A hexagon is S equals 186 minus 2, so 180 times 4 is 720. In a regular octagon, you'd first find the interior angle sum, 8 minus 2, and then you divide it by 8 because there's 8 sides and 8 angles in a regular octagon. So if I divide it by 8, each angle would be 135 degrees. If I wanted to classify just means to create all the names. So I always start at the top of my flowchart and go down. Quadrilateral because it has 4 sides. It's rhombus because it has 4 congruent sides, and it's also a parallelogram because it has 2 sets of parallel sides. Thanks for being here. Make sure you ask for questions and let me know if you need help.